And it's my pleasure to announce the first talk, which is given by Sascha Mikolajewski. And he's talking about mapping the Rima Bode region, a potential landing site for future lunar exploration. Sascha, all yours.
Yep, I hope you can hear me.
Yes, we can hear you.
Nice. And I will give you a quick introduction about the geology of the Rima Bode region, a potential landing site for future lunar exploration. First of all, where is Rima Bode located? It is next to Mare Imbrium at 12° north and 4° west. It is also a good candidate for in situ resource utilization because it's rich in titanium and also volcanic glasses, which could be used as building materials. And the current map material available for the study area are the old LEC maps from Mare Vaporum and the newer Unified Global Moon map. So both maps are mapped on a larger scale. I think roughly about 1 to 1 million and 1 to 800,000. And our new preliminary map of the study area is mapped at a smaller scale. Our mapping scale for our study area is at around 1 to 200,000. So let's have a closer look on our study area. So the green box marks the study area. Let's have a closer look. So we have here our study area. We have here Sinus Estium and here part of Mare Vaporum, and here is our study area, which is the area of most interest. And here you can see the name giving Rima Bode. So I will talk to the geological units we found out, and at the end I will show you the geological map we constructed of that. So the first unit we have is the Montes Apenninus unit, and is mostly ejecta from the Imbrium impact. It has a hummocky rough surface and shows also part of the Imbrium sculpture. And the next unit is the Framaro Formation located here. We have also here at the bottom the Imbrium sculpture. The Framaro Formation here is smoother compared to the Apenninus unit and is also a bit brighter in albedo compared to the Apenninus unit. The next unit we have is this hummocky area here. It has a darker albedo compared to the Framaro Formation and is a bit more hummocky compared to Framaro. And it could be the remnants from the buried crater, which is later filled with material from Sinus Estium. The next unit we have is this smaller plains unit here. It has a higher albedo compared to Framaro and is smoother compared to Framaro and is also topographically lower than Framaro. The next unit is a volcanic unit here and here. It is the oldest we found so far. It is the Imbrium Mare unit in our study area. It has a smoother surface. It is topographically the lowest part in our study area and is also darker in albedo compared to other units we found in this study area. The next unit is here next to the names giving Rima Bode, also where the constellation site from NASA would be located. We see here that it's also has a smoother surface, but it's a bit higher than the aforementioned volcanic unit. So following up, we have here a volcanic unit. It is cut off from the main area here by this unit here and also by this hummocky unit. It could be fed by a rill structure we found here, and also at the edge of this crater there is a rill which could be the source region for that area. Next we have this volcanic unit here, and also this is also found on the eastern part of our study region. It is topographically higher than EM2 and shows an age of 3.7 gigayears and a resurfacing event at 2.5 gigayears. And our next unit is here, north of Bode C. It is topographically lower than this unit here. And there's also an age difference because this unit here is a bit younger than this here, as shown by Hiesinger et al. In 2022. So our last unit in the Imbrium series is here. It is a bit higher than EM2 and EM6, and possibly source region for that could be the volcanic material coming from the Rima Bode. And then we have our first pyroclastic deposit area here and here. Both have the same albedo. It is darker compared to the other units we have covered so far. The surface area of this unit is smoother compared to the Fra Mauro and Montes Apenninus unit. And our next unit is this pyroclastic deposit here compared to this unit and this unit. It is darker. The surface of this unit is also relatively smooth, but the albedo is darker than this and not so hummocky than this in this unit here. And last but not least, the latest volcanic event in our study area is here. These two Eratosthenian Mare units, they have a darker albedo compared to unit EM2 and EM5, and it's also traceable in the mineralogic data from Clementine. So we also have different crater units in our study area. As you can see here, we have some Eratosthenian craters, some Imbrian craters, and now we will add the contacts, adding the line work, adding the geological structures in our study area, and surface features like the ejecta from crater Eratosthenes and crater Copernicus. And with that, we have our geological map for our study area, and now we can compare it with the other maps we have so far. So first we compare it with the old LAC map. You can see some difference. For example, I picked here the crater units in the old LAC map. It is marked as Copernican, and we found out that an Eratosthenian fit would be more accurate, judging by the morphology of the crater and the worn-down crater rim. And we can also compare with the Unified Global Moon map. There you can see that they also have these craters marked as Copernican, and here these craters here are completely left out. So for future work, we will focus more on adding some different stuff. And for example, here you can see Bode E in close-up. In future work, we will also map this landslide material, because you can see that it's clearly younger than the crater itself. And another example would be the crater Bode C, where you can also see the dark streaks of pyroclastic deposits excavated by younger impact craters. And you can see also the embayment of mare material on the rim of the crater. So what will we have done in the future? We will refine the borders between the aforementioned units. We will add the younger landslide material. We will carry out a detailed landing site analysis, which will include the rock abundance map, a slope map, and detailed rover traverses following the work from Hiesinger et al. 2021. So Rima Bode the Rima Bode region is a promising landing site. The study area was a volcanic and tectonic active region. we identified several Mare units, also different pyroclastic deposits and rills. We covered also different tectonic features like wrinkle ridges and graben, and our higher resolution map would improve the landing site analysis. So to sum things up, the Rima Bode region would be interesting for ISRU. It is located on the near side, which would be good for communication, so you don't need a relay satellite. The area is rich in titanium and volcanic glasses. With one stone, we could kill two birds, because we have several sample locations in our study area. We have Mare basalts of various ages. We can sample wrinkle ridges in close proximity to Bode C. We could also retrieve samples from Copernicus crater array or Eratosthenes crater array, which would improve the lunar chronology function. And our high resolution map, which would improve landing site analysis and gives new insight in lunar volcanism. And with that, I will finish my talk, and I'm open for questions.
Thank you, Sascha. So there's one by Alessandro Frigieri. Sascha, great work. Thanks for that. The question is, how mapped units Monte Appenninos and Framaros are different?
Yeah, they are different. We mapped them based on the morphology of the units. The Montes Appenninos is more mockery compared to Framaro. Framaro has a smoother surface, also has fewer large craters compared to the Montes Appenninos unit, and in the Framaro formation, the sculpture of the Imbrium impact is more visible. So that are the difference in why we mapped both units different. I hope that covers your question.
Okay. Are there? Yes, thanks, Sascha, is the response from Alessandro. So thank you, Alessandro, for the question. Are there other questions for Sascha? If not, then thank you again.